So exercise related to pressure. If you have question or a doubt, we can ask your doubts. Question number 1, part A1, A2, A3, B. Any doubt?
I have a doubt on the written question, the last one. This one, yes.
The force needed to open the lid is not equal to the value we calculated. Suggest 2 reasons. Look, for example, we want to open this box. So, example, let's say we calculated the force needed was 10 Newton. But practically, the force which we need won't be equal to 10 Newton. It will be different. What could be the reason for that? The reason is in this box, there will be water inside and there is water outside as well. So when we are like there is a force from the top and there is a force here from the bottom. So as a result, the force which we practically require to open, because we assume the box is inside the box, like air is there. But what if the box contains some water as well? So the force, if this force is let's say 20 Newton and this force is 5 Newton. So how much force we need to open minimum force? So at least we need 15 Newton to open the. But what we consider right now, the box is there, which is not having any water inside when we are calculating that. So there is a force from the top. Example, the force on the box is say 100 Newton. So what is the minimum force I need to open the box? The minimum force I need to open the box is 100 Newton as well. But what might happen? Maybe the box contains some of the water. So water will apply an upward force, which we also call an upthrust. So if the water, let's say apply a 20 Newton upward force, so I don't need the same 100 Newton to open. I need less than 100 Newton to open this.
Hmm.
So that is one reason. The second thing is, as you can see, when we open this box, this is a point, the hinge here, this point is the hinge or a point of rotation, and we are applying and we are opening the lid. So from position where we apply the force, that will also decide how much force we have to apply. Like example, if I apply a force from a greater distance from the pivot or a point of rotation, in that case, I have to apply a smaller force. But if I apply a force near the pivot, then I have to apply a greater force to produce the same turning effect. So
Hmm.
what could be the reason here that the position or a point where we are applying a force, because we want to open the lid. We want to cause the same turning effect. Example, we want a turning effect of 20 Newton meter. So if I'm applying a force further from the pivot, my force should be less. But if I'm applying a force closer to the pivot, then I have to apply a large force.
Oh, okay.
Another thing, when you're opening the lid, there is a drag force from the water. The water will try to oppose the motion. So that's why practically you have to apply a greater force or a different force than what you calculated.
Hmm.
And we also ignore the weight of the lid. The lid will also have some weight, but we ignore that. We did not use that in our calculation. So the weight of the lid is there. So we have to apply a force to overcome this downward force, as well as there's a force. When we calculated, we just calculated like if a water is applying, let's say 100 Newton force. So we need a minimum 100 Newton to open it. But what will happen? The weight of the lid is also acting downward. Maybe it is 2 Newton. So we don't have to apply 100. We have to apply at least 102 Newton to overcome this downward force. So these
Hmm.
are some reasons why the calculated value will be different from the practical value.
Oh, okay. Thank you.
Anyone else having a doubt? Question 1, any of the part A, B? Question 2, any doubt? Question 2, part A, 1 and 2.
Teacher, for number 2, the formula was WAAI. The formula was W is equal to mg, right?
You mean the first one, A1?
Yeah. The formula was W is
Yes,
equal to mg.
mass times the gravity.
Yeah, which is 4.8 times by 9.8, and that gives you the answer, right?
Yes, the gravity you will take as 9.8 and the mass is given.
Yeah, teacher, but can we take it as 10 also, or it's not allowed? No.
Can we?
Can we
No,
take
no,
the,
no.
like I also saw, no,
No,
it's
no, in the
9.8.
actually, when you see the recent past papers, like the
Hmm.
recent exam papers, I mean, that you will find that they mention that they take gravity as 9.8.
Oh, okay.
Then 2B, okay. Explain why the total pressure on the base of a container is greater than the value calculated. Look, there is a container which is filled with a liquid. So we calculated the pressure exerted by the liquid. We calculated here the pressure which is exerted by the liquid is equals to density, gravity, and depth. So let's say when we calculate this example, say it is coming out 100 Pascal. But what they're saying, the total pressure on the base is greater than what we calculated. Like if we calculated this as 100 Pascal, but practically it will be more than 100 Pascal. What is the reason for that? Because the atmosphere is also exerting pressure. So there is a pressure of the atmosphere and there is a pressure of the liquid, and that the two combined together, that will make the total pressure. So there is a pressure due to the atmosphere, or atmosphere will also exert a pressure. That's why the total pressure is different from what we have calculated, because we just calculated the pressure of the liquid, but the actual pressure will be the pressure of the liquid plus the pressure of atmosphere. So why the total pressure on the base is greater than the value we calculated? Because of the atmospheric pressure, or the pressure of the atmosphere is also acting. Question 3, part A, B1. Any doubt? Anyone having a doubt or a question in this? No doubt. Question 4, any doubt? Question 4. Anyone having a doubt or a question in this part? Question 5. Question 5.
No, sir, I just want to confirm my answer. For I wrote, it said state by velocity and acceleration are both described as vector quantities. So I write, my answer was velocity and acceleration are described as vector quantities because they both have magnitude and direction. Is my answer correct?
Yes, right.
Okay.
Okay, no doubt in this. 5. Question 6, any doubt? Question 6. Okay, I will solve question 6. In question 6, the moment of the weight about a pivot is 12 Newton meter. So this is a moment. The perpendicular distance of a line of action of a force of the steam and the valve is 0.2. So this is a perpendicular distance. The area is this. First, the minimum for steam force we need. So how we work out the force? If we have the formula is moment equals force multiplied by perpendicular distance from the pivot. So moment is 12. The force we don't know, and the distance from the pivot is 0.2. So 0.2 is multiplied. Other side it will be divided. So it will be 12
So
divided
that would
by,
be 12 divided by 0.2, right?
yes. So this will be
Which
12
will give you
divided
an
by 0.
answer of 60 Newton.
So it is equals to 60 Newton. Now we have the force, we need the pressure. So how to work out the pressure? Pressure is force acting on unit area. The force is 60 and the cross-sectional area is given as 0.0003. So 60 divided by 0.0003.
200,000 Pascal.
Uh, 200,000 Pascal. Okay. Or I
Sir,
can
I just have
also
one more
write as
question.
2 exponent 5.
Can we,
Yes.
if we write it in 200,000 Pascal, will you still get the mark?
Yes, you will score the marks.
And what, like, when do we write it standard form then? Like,
Actually,
is it?
look, if the number is in the range, standard forms are like if you see a numbers in thousand, write in standard, or if numbers are like two decimal places are written 0.0025, then also write in standard form.
No, okay.
Next, we have question 7. Any doubt? 7 part 1, 2,
Sorry,
3.
yes. I just want to check if my
Okay.
the written question. I just want to check if my answer is correct or what
Okay.
I wrote.
A man squeezes a pin between his thumb and the finger as shown. As you can see, a man squeezes a pin. Finger, pinhead, pin, and the thumb. The finger exert a force of 84 Newton. The pinhead has an area of 6 exponent minus 5 meters
So
square.
the formula for this will be P is equal to F over A, and that would be 84 divided by 6.0 times by 10 to the power of negative 5, which will give you an answer of, how much would that be? That would give you an answer of 1.4 times by 10 to the power of negative 4
Pascal. And
Pascal.
remember, if we apply a force, look, if we apply a force of 84 Newton here, so how much force will be there on the other end? It will be 84 Newton. Force will be same. So same force will be there on the thumb, same force will be there on the finger. State the value of a force exerted by the pin on the thumb. So how
You just
much
84 Newton, it's
84
same.
Newton, we just have to write directly. Explain that the pin caused more pain in the man's thumbs than in his finger. What is the reason if you compare the cross-sectional area?
Because the guy is applying like more force on the finger, that's why.
No. Force is same. You are not supposed to
Oh.
say, look, that is important, like how you write the structure of an answer. Look, this is a pin. Example, this is representing a pin. He is applying a force of 84 Newton. The other side also the force is 84 Newton. But why it hurts more on the thumb rather than the finger? Because the area which is in contact is less with the thumb. So if the area is less, it means the pressure will be, the force is same. But if the area in contact is less, so means the pressure will be greater on the thumb. Here the area in contact is greater because pressure is force acting on unit area. So if the area is greater, the pressure will be less. Clear? So you have to relate that the area in contact with the thumb is less. That's why it will exert more pressure or experience more pressure, which cause more pain in the thumb compared to that in finger. Part B1 and 2, any doubt of the same question? Feel free to ask your doubts. If you have doubt in the whole question, I will discuss. If you have any part as a doubt, I will discuss that. Question number 8, any doubts?
Teacher, yes, on the written parts. This one,
Okay.
the force, yeah, all of that, yeah.
Question 8. During a period of a hot weather, the atmospheric pressure on the pond remain constant. Water evaporates. Okay. Look, if this water will evaporate, what happened to the depth? Will it increase or decrease?
Decrease.
It decreases.
Decrease.
So if the depth of the water, because the amount of water decreases, so the depth decreases. If the depth decreases, what happened to pressure exerted by the liquid? It will also decrease. Because the pressure exerted by the liquid depends on the depth, depends on the density. So they mention here that study the diagram and state, giving your reasons what happened during this hot period, force of air on the surface of the pond. Now, how to identify this? If you compare, because the pressure is not changing, okay? And we know the pressure is force which is acting on a unit area. So, pressure is force acting on unit area. Pressure is remain constant. They mention this pressure does not change, pressure of atmosphere remain constant. When the water evaporates, what happened to the area? Area of the surface area of the water. This is the area first. Let's say the water evaporates and this blue line is representing the new area. What happened to the area? Does it increase or decrease?
Decreases.
It
Decreases.
decreases. So if the area is decreased, so the force should also decrease, so the pressure remain unchanged.
So
How
they're
it
directly
happened?
proportional.
Yeah, force and area are directly proportional if pressure is constant. Look, you have a formula. Pressure is force on unit area, or pressure times area is equals to force. The pressure is not changing. They mentioned that in the beginning of the question, that the pressure remain. This shows that the pressure remain constant. They mentioned that. So if the pressure remain constant and the area is decreasing, so the force should also decrease.
Decrease.
So what happened? The force of air on the surface of the pond. So what happened to that? The force of area on the surface of the pond should decrease. And why it decreased? Because the pressure remained constant. So force and area are directly proportional to each other.
Okay.
Is it clear?
Yes.
The next part, the pressure at the bottom of the pond. The pressure at the bottom of the pond depends on the atmospheric pressure, the pressure of atmosphere that is not changing, and it also depends on the pressure due to liquid. And the pressure due to liquid depends on density, gravity, and depth. Because the depth is decreasing, so the pressure exerted by the liquid will also decrease. So what happened to the pressure at the bottom of the pond? That will also decrease. And why it will decrease? Because the depth is decreasing. So both answers are decreasing. One is because the area is decreasing, for the surface area is decreasing. Another one, the depth is decreasing as well. Is it clear?
Yes, sir.
Part A1 and 2. The next is on a certain day, it's 12-meter deep and 1000 is a density of the water.
Teacher,
We
so we
have
have the formula P is equal to DGH.
yes, the density,
Yeah, and
the
then
gravity times depth will get the pressure.
yeah, which will be 1000 times by 9.8 times by 12, and that'll give it the whole answer.
Yeah, there is one question from the student: at what scenario we should add to get the total pressure? Look, if they say pressure exerted by the liquid, the pressure exerted by the liquid is density, gravity, and depth. If they ask us what is the total pressure at this point, so total pressure at this point, pressure of the liquid plus pressure of atmosphere. So if the question was find the total pressure exerted at the base of the pond or the base of the container, then it is the pressure of the liquid plus the pressure of atmosphere. But if they ask us find the pressure exerted by the liquid only, then you will use density, gravity, and depth. So the question will be different related to the finding a pressure by liquid or the total pressure. Question 9, any doubts? 9A and B.
No, sir.
Anyone having a doubt or a question? Question 10, any doubt? No doubt in question 10 as well. Okay. Question 11, any doubt?
Sir, I have a doubt on in 10B part 2.
Suggest 2 reasons why the tension in the cable is not 3 exponent. Look, what will happen? Let's say this box is example. Let's say this box is 2 Newton. So how much force do I have to apply to lift this box? Minimum force. If the weight of the box is 2 Newton. So I have to apply 2 Newton upward. And when we apply force by using a wire or a string, what is the name given to that force? We call that as a tension. Okay. So when we apply a 2 Newton upward force, but when the object is underwater, now the water also exert a force that is called an upthrust. So if the weight of, let's say the weight of the block is 2 Newton, which is acting downward, and the tension is the upthrust is 0.5 Newton. So how much tension I should apply? How much force I should apply by using a string? So minimum force I have to apply 1.5 Newton. So when the objects are underwater, the water exert an upward force or upthrust. That's why we don't have to apply the same amount of the force. That's why underwater it is easy to lift heavy objects as compared to outside. Because when the objects are underwater, the water apply an upward force, which is also called an upthrust, so which make it easy to lift the object. So I don't have to apply the same 2 Newton, I have to apply 1.5. So one reason is that there's an upthrust force or an upward force from the liquid. That's why the tension will not be same. Another thing, we did not include the weight of the string. We ignore that. We ignore that the weight of the string, because the total weight of the string we did not include. But maybe the object was 2 Newton and the string is also having its weight maybe 1 Newton. So what is the total downward force? 2 Newton and 1 Newton. So the total downward force is 3 Newton. So means how much force I have to apply to lift this object. So minimum force I have to apply is 3 Newton. So we did not include the weight of the string or the wire or the cable. That's why the force will be different. Another thing, there's an upthrust force by the liquid that will make it easy to lift an object. Is it clear?
Yes, clear.
Question 11, any doubts? Question 12. Any doubt in question 12? 11 part C. The water supply is turned off and the valve is held open so that the water drain out. State the energy change that occur. So what is the change in energy? Like a water is there at a certain height. So when water is at certain height, it will be GP, gravitational potential. When we open this valve, the water will go out. So which form of energy it will have? It will have a kinetic energy. So the gravitational potential energy of the water is turning into kinetic energy. That's a change in energy. Kinetic and sound also, you can say kinetic and sound both together. Question 12, any doubt? Question 12. No doubt. Question 13. Any doubt? Question 13.